Okay, seems to be work. Oh, yeah, it is. Alright, welcome back. I have been gone for a while. In last week, streamed like twice. Oh, I don't have much of an excuse. I was just lazy. But anywho, that's in the past. See, I'm here now. Kinda don't remember where I left off. Let's see, does it still... I think I did the mouse. Yes, but I don't think I did... What about click? Okay. Oh, that's why. The second button is the center button. Scroll up, scroll down. And then I think other buttons. 9, 8. I don't know where 7. 6 and 7 are missing. Oh yeah, but this is cool. Coordinates are like correct. Doesn't include the title. Click. Okay. I don't think the recording will work anymore. Hang on, I can get rid of those. Debugged up. Yeah, I print this out elsewhere. Playback input. Oh yeah, yeah.
And the other thing that I wanted to do, again, just miscellaneous cleanup, is one thing that I did notice is we don't pass any mouse input to the game. And we don't need that for any particular reason because we won't really be supporting the mouse as a controller. Like you'll be playing with the keyboard because it's kind of more of a digitally kind of game. So the mouse isn't really probably going to be appropriate. But what I would like to do in case we want to develop some debug overlay systems that might be more appropriate for using with the mouse, or if we want to use the mouse to like move elements in some kind of an editing mode or anything like that, what I would like to do is essentially introduce here just some mouse debug stuff, right? So, something like, a mouse buttons flag and a mouse X, mouse Y sort of a situation. Just something like that where we can sort of pass the mouse information to the game. And it can be super janky and awful. It doesn't even matter because it's only going to be used for our debugging purposes. But, I just kind of would like to have something like that in there. And maybe we'll use the half transition count thing. I don't know if that's a good idea. Maybe we'll use the half transition count thing for that since everything else uses it. So maybe we'll do something like this where we do mouse buttons and we say, okay, how many mouse buttons are there on this thing? I think there's 5 on this thing. I don't know if mouse button have so many mice have so many buttons these days. And then of course we've got a mouse Z, I suppose, as well, which is that little mouse wheel thing. And so I just want to create that state there, have it so that the game can get it. And also, let's go ahead and just drop in, something where we can see if we're actually passing that correctly, and then I'll pass it correctly in Win32. So we have we have the render player thing, right? We have a render player call. Let's get that up above my head. And so maybe we'll just go ahead and say, let's render where we're getting told the mouse is, right? So we have a mouse X in the input layer, and we have a mouse Y in the input layer. So let's just go ahead and do that so that we can see that we have that mouse cursor position. And then I will go in, that should compile now, I think. Yeah. I will go in and just add the minimum necessary nonsense to get the mouse out. So basically in here, if we only care about where the mouse is right before we call it, really, okay, so when we process our like X input stuff, we do our controller input stuff, we can do it right here. We have that new input pointer, right? We have new input, and we just want to go ahead and set these values, all these values here. So that'd be mouse X, new input mouse Y, new input mouse Z. I don't know if we can get in the way that I'm about to do the other ones, but if we don't support mouse wheel right now, I don't really care. That doesn't actually matter to me very much. And then we'll at least track those three buttons as well there, or buttons as I occasionally say them. Nice spelling there, Casey. So what we can do if we just want to, if all we need is just some mouse information, there's actually a get cursor pause function in Windows that will basically tell you where the mouse is at any given time. It's pretty trivial to use, right? Basically what you do is you call this, and the main cursor, whatever the main mouse is on the system, wherever this little thing is that I'm wiggling around right now, when you call that, you can just get wherever it thinks that thing is. So basically, we can say this is the mouse location. We can get that, and then we don't even care if this thing fails or not. It literally does not matter to us because this is strictly debug information. So we can then take a look at this point structure that comes back, and it gives us this long X and Y. Now the problem is if we use this directly, well, you know what? Let me show you what happens if we use it directly, so that you'll.
Hang on, I do remember that. But then I don't remember what to do now. And 32 as well. Key release time. Key 32. Guess these could be this U32. 00 is the smallest value. Ah, fuck it. I don't have to. Oh yeah, and I need to know which mouse button. 1, 2, 3. I think 3 is enough. Will this now work? I just keep track of which mouse button is pressed. I don't know, let's keep it simple for now. Figure the rest out later. Oh, I could have used the debug statement. Lookup key symbol. No, we don't need this. Yeah, I don't need that. Key released. What's this? Oh, hang on. This is not right, is it? I need to do that better. Okay, hang on. This won't work. Make it a slice of no native U32. 20 should be more than enough. Oh, if the actually 10 is fine. 1, 2, 3. What was 2 again? Oh, I think it was the middle button click. So I just need 5. 1, 2, 3, 4, and 5. When it's released, I'll just remove it from the array. Actually, why does it need to be a U32? Can it just be a boolean? What is what was this number? This was the button. Let's have a look at the button event. Mic check. Okay. Type serial send event display window root. Sub window time XY root state button. Same screen. There is a time. Let me check. X11. I did save the docs. Yeah. Yeah, there we go. Button event. Button press or button. Oh, interesting. Well, there's a separate event though. Makes it easier. Number of last requests processed by server. Event window. What is this time? The X server sets sub window member to none. The time member is set to the time when the event was generated and is expressed in milliseconds. Okay, for now, I'll leave that out. So what do I save? What does Casey save? What does it save here?
Understand exactly. Really all we need to know now is we need to know whether or not we had a mouse button up or down. So the way we could do that if we wanted to is we can sort of do that in line with that with when we sort of do all that keyboard processing, you know, this sort of stuff. So what we could do there is we could say, all right, let's go ahead and process mouse up, mouse down messages here, right? We could, I think we also could get them. We might be able to just kind of. I'm so torn. I'm so torn. It depends on how robust we actually want our mouse processing to be. Since it's just debug, I'm tempted to not even bother. and maybe just see if we're fine. Basically, I'm tempted here, ladies and gentlemen. What I am tempted to do, I will tell you. I am tempted to just go ahead and just query it straight away, right in here, and just see. Oh, it's.
I understand
All
why
right,
he's got
I
it.
think I'm going to do that. So I believe this is crazy. You know, don't ask me why I know all this stuff. It's such a, you know, you wish that your brain didn't even have this information in it because it's just so ridiculous that I even know this stuff. So basically, there's a function that gets the state of the keyboard for you. And it's the state of the keyboard as of your last message that you pulled off of the message queue, because Windows tracks that for you. And so you may be asking, why would that matter at all? Why would we want to do a get key state call? And you can see that it returns the high order bit is set if the key is down, that the high order bit is not set, then it's not down. And it's a short, so it's 16 bits. So basically, we could use this to see whether keys are up or down. And you may be saying, why would you care about that, Casey? Because we are not looking at the keyboard, we are looking at the mouse. Well, if I remember correctly, and sadly, I think I do remember correctly, you can actually ask for the mouse cursor VK code. So basically, if we do something like...
Okay, I think I kind of have an idea. For now, I just make this flags. I'll think about it later. I'll update it later. I can save. Is the mouse X updated? Motion notify. Okay. Can update it there. If button pressed less than equal to 5. I don't care about the other buttons. Game input, mouse buttons off. If button pressed to 3, that's no 4. Say plus equals 1. Scroll up. Okay. Don't need this. Actually, in that case, I only need 1, 2, and 3. Okay, that should be good. I don't think it builds at the moment. $74. I think there should be 0. Buttons. Do I need to initialize that? Okay, it's missing. See if I can get it to build. No field named key. Is that 256? Yep. I'll make this better later. Just want to get it to build for now. Okay. I don't think the recording will work. Press a few. I should have. I need a way to see the mouse. Yeah. I figured. I think it's because the. I know why it's happened. Because the refresh rate's gone up. But I wonder why. Should be recording at the same refresh rate. Okay.
All right, so that's all we really needed for mouse, however you want to say that. Debug mouse cursor, done. And I don't see anything else on this list, to be honest with you. So I think that's basically it. So there we go. I'm going to go ahead and slam in the slightly potentially more optimal version of the replay code because I don't really know why, just because some people were nervous about how long it took. And so we might as well spend a little bit of time, since it's not particularly difficult, basically using all of the crazy huge amount of system resources that we have now to speed it up. Because, I mean, hey, if you're going to have machines, you know, this machine, I don't even know how much physical memory this thing has. Let's see. So this thing has, why? So total. So I guess that's telling me we have 12 gigabytes of memory. Is that what we want to say there? Let's say that that's true. So if we have 12 gigabytes of memory and we're only taking so yeah, so we can just abuse the physical memory in this machine. We can just you know what? I think it's time. I was going to save this for the right time, but the right time may be now. I think it's time to get piggy. That's what I think. I think it's time to just like be a total pig and just use all the memory in this machine because it's there, right? So I don't see any reason why we shouldn't just go to town. It seems like if we've got the pig hat on, nothing's going to stop us. So let's just go ahead and say, because we can, that what we're going to do here is we are going to create backing stores for all of this stuff, right? We're just going to go ahead and create backing stores for this game memory block. So we'll do that one way first, and then we'll do it in a slightly different way immediately thereafter. So
Oh yeah, I think I know why the playback was a bit fucked. Also, why is... What's this doing here? Because I think it had some... back. I think this might be wrong. Yeah, because it's the old one. Probably why. Because I might have had some saved state. Or like, yeah, when the frame rates were much lower. Now if I record... Still a lot faster. Don't know why. That's why I want a pause button. Recording file. Okay, so right now when I... This is kind of stupid. Let's save this. Yeah. Get rid of this. This. Saving key symbol. Yeah. this doesn't need to be here either. I can get rid of this one. Okay, the record button can be the same. Don't want to run playback immediately. Also, key symbol equals. It's recording, it'll stop recording and then play. And call it S for now. We don't use the keys anyway. We can stop playback. Stopped. Paused. Because it can keep running from there. If that works. Recording. I should stop. Why did it stop playing? Oh, yeah. Stop, play, pause. That's pretty cool. To save this in memory, let's have a look.
What I'm going to do is I'm going to say that we have a particular count and of these Win32 replay buffers, right? And basically the Win32 replay buffer will have a void star pointer to the memory block like that. And then I'm going to have this here. And maybe what we'll do too is maybe we'll say what the backing file name is. So we've got the replay file name like that. I don't know. I don't know how necessary that's going to be, but we'll go ahead and do that. I think that should work. Okay, so we'll say that there's the replay buffer, and these are our replay buffers, and we're just going to say that we have 4 of them. Why do we have 4 of them? Because I said so. That's how many we're going to have. And so we will go ahead and move that up here. So we have the game memory block, which is our actual memory block, and then we have the replay buffers, and they have their game memory blocks inside them as well. And so what we'll do now, just to start with, is we'll just virtual alloc buffers, and instead of writing that state to disk, we'll write it just to the buffer real quickly and see how much performance benefit we get there. So basically, if we compile this, if you remember where we were at before is, let me grab my little gamepad here. We were moving the guy around, and you can see when we hit that loop, there was this big old pause, right? Real long pause while it wrote that stuff to disk. And so what we want to do is see if we could speed that up. We want to make that faster.
Crazy how much better hardware's gotten. There's no pause at all when I write it. Build, run. Start recording. And stop. It just stops instantly. Maybe I can see if the frame rate goes down. I mean, it might go down a little bit. I wasn't recording. Because I don't print desktop. Oops. Yeah, there's almost no difference in the frame rate before or after the recording. That's pretty cool. Yeah, hardware's gotten way too good. So I don't even need to write it to memory. Sorting out write file for copy memory, testing new recording technique, performance profiling. I'd like to see this.
Handle. In fact, what we could do, you know what? I'm going to use a little, because we don't have a profiler yet, I'm going to go ahead and use output debug string to sort of spam things here, and use a little technique that I often like to use, which is basically just going to go ahead and spam, I'm going to spam indexes out to the debug port, right? And I'm going to spam them at each particular location so that we can see who stalls, because I don't really know who stalls. This is not a glamorous way to do it, but you know, in short order, it's something we can do. So let's go ahead and size that down there. Get the output up. There's our output. So here we're going, and then we go L. So did you see what happened there? That was pretty interesting, I would say. It actually got to here relatively quickly. So something after begin recording input is actually causing the problem. Win32 begin recording input. So we just have a flat out regular old bug that was presumably causing problems for us even before. This is very good. I feel like this is a good thing that we looked into this, because we just have some other totally erroneous behavior happening, probably down in here somewhere. We just have something stupid going on, if that makes sense. So I want to see. I'm interested to know, yeah, what exactly is going on there, because that was an interesting stall. It stalled right after spam 4. So let's. I guess I could step through it maybe and see, because remember, it printed spam 4, right? You saw what happened. You were here. It printed this, and then it didn't print this for a long time. Now, if you could think about what that means in terms of flow control, in terms of what happened in the code, it means that we got, I can never find my way around in MSVC. We got here, right? And then when we exited from that, you remember Win32 begin recording input is called here. So we did whatever we were going to do here. We exited out of this function of Win32 process pending messages, right? And then we actually, you know, I don't know what happened. We executing this part of the code, just executing through all this. For some reason, this time around, before we ever got to the frame output stuff, because we still output the frame, we still output this stuff, right? What did we output? BTL 33. Okay, so basically, spam 4, before this line right here, the BTL line, is all the way up here. And so something in between, in between when we called the right up here, which is happening here, in between there and that BTL line took an enormous amount of time. So I wonder if we could figure out who that is. Let's just see if we can. What's the name of this function again? Win32 begin recording input. Yeah, this guy. Let's see if we can figure out who's responsible. Just really simply. Again, a profiler would make this very simple, but we don't have one yet. So we're gonna have to do this the old-fashioned way. So here we go. We're going. We end up in here. This happens. That copy takes a little bit of time, but not that much, right? And so we come out here, we go through, let's see what happens. So we come out, we come in here, we get these things, we process the keyboard messages, we go ahead and get our X input state, we do this a couple times, we finish all the controllers, none of them are connected, we come through here, we try to record the input, we call the write file. What? Very interesting. So it's as if the write file. So I guess it's because the write file is having to actually reserve all when you do that set file pointer call, is actually reserving all of that space or something of that nature. Let's see if that is true. Set file pointer ex. Let's see what happens if we get rid of this this file pointer situation here. There we go. If 0. There we go. Let's see what happens if we go ahead and do that. Yeah, so that's way faster. Right? Way faster. Very interesting, people. Very interesting. So basically, the act of setting the file pointer appears to be forcing the operating system to actually go through and do all of the work on that span, which we really did not actually need it to do. So I'm not sure how to solve that problem exactly. I'm not sure how to tell it that we don't care very much about that. We could make it so that we have two separate files, one for the input stream and one for the backing store. I don't know. I do not know what we want to do about that. So what I was going to do, I'll tell you the rest of what I was going to do, is I was going to go ahead and do a memory mapped file, which is basically where you tell Windows that a portion of memory is just supposed to be mapping a portion of a file. I was going to do that for the memory block, and so that way Windows would just commit it to disk when we closed or crashed or whatever, and wouldn't.
Oh, interesting. I didn't know about that. Memory mapped. You do that on Linux. mmap. Creates a new mapping in the virtual address space of the calling process. Starting. Where's my mic making weird noises? Starting address of the new mapping is specified in adder. Okay, so I just point to the address. The length argument specifies the length of the mapping. Okay, that's pretty cool. I can use the header, or maybe, but there's os.mmap. Okay. There's usually a method that works on either. Cos6mmap. Standard C.mmap. I guess that could work as well. Jeez. Excuse me. Mmap 64. Align page size. Blend protocol flags. File descriptor and offset. What about the other mmap? I think except the offset, it's mostly the same. Maybe the flag as well. This is interesting. The part that I don't understand is how would you read? So you would read from this file into, yeah, how would the other side work?
Think that it needed to write stuff all the time. Now, I don't actually know if Windows, I don't actually know if Windows will be smart enough if I do that memory map and then we do the set file pointer thing. I don't know if it'll be smart enough to know what to do and not to do what it's doing right now, which I assume is that it's taking the time to go ahead and pad out that file. Yeah. Yeah. So very interesting. And you can see, in fact, too, loopedit.hmi is very tiny when we don't do that, and so it's very big when we don't set the file pointer because it's only recording just the input into there. Yeah. So I don't know what we should do. I don't know. Maybe we should try the memory map file thing and see what happens, just for education purposes. I don't know. Or maybe we shouldn't. Maybe. Let's just try it. Let's try it. Let's do map view of file, and we'll see what happens.
memory. Function a map into process address space. Allows direct memory access bypassing traditional I/O operations. Often null to let the system choose. Okay. How about how if you set it to null, what does it write to the file? Mapped memory is standard OS map. Oh right, okay, when you create the map. And you can specify, I guess, how much memory you want. What is it turns in any opaque? What if we use returns nothing? Just to use sorry, just number of bytes written or read. You gotta provide an address, a length. Often file, buffered reader. What did he do? Oh, he just implemented read file alloc. This guy is getting grieved. I mean, so far from what I've seen, reading from the file seems to be a lot easier. It's not really that slow. Ah, never mind. Gonna move on. What's next? Introduction to game architecture. Let's have a look at. Okay, then it goes on to like building the actual game. This is where I think I would like slightly, not slightly, I would diverge. It does some D basics. That's pretty cool. Yeah, because I don't really want to build a game. I wanted to know how the platform layer is built so that I can build something with it. Well, my debugger wasn't working, so I thought maybe building a debugger. Not such a bad idea. There are some things in here I'd like to watch. Like, try, at least. Not all of it, maybe. I did see some of them here. For instance, this section. Let's just have a look what this looks like.
10 minutes over today because we're going to need the time. All right. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game from scratch live on Twitch. No libraries, no engines. This is essentially a series about how to program everything in games. So we cover everything, including how you would program an engine if you were making your own. And today we're doing a topic that is one of those topics that is straight to that point, because it's not something that you might do that much of if you're just doing very sort of fluffy, high-level game code, and that is optimization. So let's talk about optimization. What it is, how you do it, everything about optimization. First of all, I'd like to start with a caveat, which is I am not one of the world's best optimizers. You are not going to be getting any incredible gems of wisdom from me here. I am a good enough optimizer. I optimize code enough to get it to the place where it needs to be for shipping purposes, but I am not one of those people who you go to when it's like, oh my god, we have this thing and it needs to be optimized within an inch of its life.
Hang on. What I'm thinking is I'm just gonna jump ahead for a few episodes, not all of it. And close these, I think. Maybe watch this section here. And then I want to see how it renders font. Where is it? I did see it somewhere here. Yeah, here. I like to see the font stuff. Oh, and I like this too. Okay, I'm gonna pick and choose from here on. Guess I'll start from here tomorrow.
I am a good enough optimizer. I optimize code enough to get 10 minutes over.
I'll just start from there tomorrow. The only challenge might be following. Well, actually, I never really looked at the code much anyways. I should be okay. We'll see how it goes. Good. All right. Okay. I think I can call it a day though. Yeah. It was good to stream again after a few days. I really do enjoy streaming. But it's it's the starting up that. What's this? I can close that. I'll move this here. Oh, because it's pinned. Yeah. It's just the showing up that's the hard part. Okay, anyway. I'll continue on from here. Watch some of this debugging stuff, see how it does it. And then we go from there. Sounds like a plan. I do want to build a debugger for myself because I've tried a few and I'm not really like pleased with any of them. I mean, most of them don't even work. I'll see if there's an easier way to do it. I am counting on my ignorance to get me started. Because I think it's like, how hard can it be? We'll find out, I guess. Okay, I think I'm gonna call it a day. Thank you for hanging out, as always. Although there's nobody here. It doesn't matter. And I'll see you back here tomorrow.